Section 8 is systems of quadratic and linear equations. So back in chapter 6, we did systems of equations. Those were all lines. This section involves systems that are parabolas and lines. We could have really any equation and some other equation making two different graphs. It doesn't have to be just parabolas and just lines. It could be any two graphs. The point is, when we graph them together and we want to find a solution, we're finding where they cross. Okay? So if we have a quadratic equation and a line, we can have them crossing in one of three ways. And those three ways are demonstrated here on this screen. So we could have the parabola and the line crossing twice, as we see on this first one. So we see them crossing here and here. We have the parabola and the line crossing once, right there. And then we have the parabola and the line, and they don't cross at all. They completely miss each other. There's a gap right here, okay? So one thing I do want to mention is this picture right here kind of makes it look like the parabola and the line would have to cross at the vertex, and that's not true. So if I redraw this picture, so I have a parabola and a line, and I could make the line come in and just touch the parabola one time, like that's a really shaky line, but that's the idea, okay? So we could have the parabola and the line touch just one time anywhere along the way on the parabola, all right? It doesn't have to be a horizontal line. It doesn't have to be touching just at the vertex. We can have that happen anywhere, okay? So we have two solutions. If the line cuts through the parabola, we have one solution. If the parabola just touches the line, and we have no solution if the line completely misses the parabola altogether. All right, so that's what we're going to be dealing with in this section. Now, we can solve graphically, as you can see here, and we can solve using algebra just like we did back in chapter 6. So we're going to practice now. To solve a system of equations by graphing, we'll graph each equation just like we did back in chapter 6 with the lines, and then we'll locate any intersection points that we might have. So graph the first one. How would we graph that top equation? What does it look like? Is it a line? Is it a parabola? Is it something else? It's a parabola, yep. So how do we start off graphing a parabola? Start with the axis of symmetry. What's the equation for the axis of symmetry? It's x equals negative b over 2a. So we have x equals negative, and what's b? 1. So a and then b and then c, right? A is always attached to the x squared term. B is always attached to the x term. C is always the constant term. So that means x equals negative, and then b here is actually negative 1. So we have negative, negative 1. Divide by 2 times, what's a? 1. So now we simplify that. That negative, negative 1 is really positive 1 divided by 2 times 1, which is 2. So the axis of symmetry here is x equals 1/2. What do we do next? We draw the axis of symmetry. So x equals 1/2 is kind of a bummer, but we can go ahead and draw that on there. It's right there. Now we can make our table. So we draw a little x, and then the function x squared minus x minus 2, and then y. Now, right off the bat, before I even think about what numbers to put in there, I know for sure I have to put the 1/2, because that's going to give me my vertex.
So we're going to go by 0.5 every time?
No, we are not going to go by 0.5 every time. We just have to make sure that we put the 1/2 in there, because that was my axis of symmetry, and that's going to give me my vertex. After that, I can pick whatever numbers I want. They don't have to be fractions, okay? But for sure, I know this negative 2 already. What is that negative 2?
0.
That's my y-intercept. So I'm going to mark that one right now. Negative 2 right there, y-intercept, okay? And then I can immediately reflect that one across the axis of symmetry. To get to the axis of symmetry, I only have to go 1/2 a unit. So I go 1/2 a unit again and mark the reflection point, okay? So when I go to fill out my table, I'm not going to choose 0 And I'm not going to choose positive 1 because I already know those. Those are freebies. Okay? So from 1/2, I could go 0, but I already know it, -1 and -2. Or I could go 1, but I already know it, +1, already know it, 2 and 3. Okay? What am I going to pick?
-1, -2.
If you like working with negative numbers, go with -1 and -2. If you don't, then go with +2 and +3. For me personally, I'm going to go with +2 and +3 because then I'm not juggling negative numbers so much. Okay? Now, for sure, I have to do the 1/2. So 1/2 squared is 1/4. Right. Now, I have minus 1/2. And then the -2 is always -2. So then it's just 1/4 minus 1/2. What is that?
-1/4.
-1/4 is right. Now -2.
-2/4.
-2 and 1/4. Yeah, don't make it overcomplicated. Just -2 and 1/4. We don't have to make a improper fraction or anything. We're just going to graph that number. So we go 1/2 and then -2 and 1/4. So that's just right there. Now, which way does this parabola open? It has to open up. We know that because that's a positive A right there. Okay. Now, by these 3 points that we have right here, does this parabola open up? Yes. So we probably did this pretty much right. Okay, so far. So I feel pretty good about where we're at. So now we can plug in the 2. We have 2 squared, 4, and then -2, and then -2. What do we get?
0.
We got 0. So I have 2, 0, which is right here. And then I can go ahead and reflect that right away. So I go 1 and then 1/2 to the axis of symmetry. So I do that again, 1/2 and then 1, and I have my dot right there. Now in a different section, we would know the answer right now because that's where the graph is crossing the x-axis. But that's not the section we're in. We're trying to find where these two graphs cross. That's different. So I keep going. I need 3. 3 squared is 9, and then -3, and then -2. What is this? Yeah, we got 4. So then at 3, we go up to 4. 1, 2, 3, 4. Here it is. And I can reflect that right away. 1, 2, and 1/2. So 1/2, 1, 2. Here we are. All right. So I'm not at the top of the grid. Should I do another point?
Well, it's going to be probably off the grid.
It will be off the grid. It'll be actually far off the grid. So there's no need to do another point. So if you remember my trick, what I do is I go just outside of the dots that we have, and then I go up to the top of the grid. So like right there, and then just outside of this dot, and to the top of the grid right there. Those are not official dots. They're just helping me draw a nice looking parabola, okay? My little cheater dots to help me get a good graph. So now we draw on our graph. Okay, and now we can make our other equation. What is this one going to look like?
A line.
This is a line. Where do I start?
Make a table.
I don't need to make a table.
The slope is -1.
The slope is -1, but where do I start?
+2.
At 2. The y-intercept is 2. Remember, y equals mx plus b. That's our plus b right there. So we go to +2. And then our slope is -1. What does that tell us?
It's going down 1 square unit.
We go down 1
to the right.
right.
Down
1.
1 right. 1.
We go up or down based on the sign of the slope, and then we go right. Okay? So if our slope is -1, that is -1 over 1. So we're going to go down 1, right 1 a bunch of times. Down 1, right 1, and we landed on a dot. So that's good. We know one of our solutions. We just keep going with that, though. Down 1, right 1 a bunch of times. And then reverse it. So instead of down 1, right 1, we go up 1, left 1 a bunch of times. We landed on another dot. So we actually know both of our solutions, but we keep going because we got to finish the graph. So now we go ahead and draw on that line. And all the way through the grid, arrows on the ends, and the graph is done. But we're not done because we have to answer the problem. Where are the intersections at? What are the ordered pairs?
-2 and 4.
-2, comma 4, and
And +3.
no.
Oh, wait, then.
2, 0. So if you do not write those ordered pairs down, then you didn't finish the problem. You didn't tell me what the answer was. Did all that work and then didn't do the last step. You're going to get it wrong. You have to tell me what the answer is, okay? Or what the answers are if there are 2. So that's how you do these problems. Graph them, find where the intersections are, if there are any, and then tell me what they are. So solve this one by graphing. What are we going to do first?
The AOS.
AOS. So x equals what?
-1.
Right? Over 2 times 1, which is 2. There's nothing to simplify there. It's just -1/2. So now what do we do?
Make the line.
Okay, so vertical line going through -1/2 is right there. Now what? Table. So we have x and then x squared plus x minus 3 and y. What goes in the table? -1/2 must go in the table. Okay, now what?
We can do the
1/4 minus 1/2 minus.
What about the -3?
it'll be 0.
Okay, that's our y-intercept.
Oh yeah.
It's the y-intercept. So there's -3 right there. And what can I do with that?
Reflecting.
Okay, so I reflect that right away. Now, a couple of things. Look at how close those 2 dots are together. That tells me that my vertex must be really close to that. And which way does this parabola open? Opens up. So my vertex must be like right below, somewhere nearby, right below there. Okay? So when I plug in that -1/2, I better get something very, very close to those 2 dots, but just below it. Okay? So now I am also going to pick some numbers. I would not pick 0, but I could pick 1, 2, 3. I would not pick -1, but I could pick -2, -3, -4, something like that. Which ones am I probably going to pick?
Positive.
Positives, because it's easier to work with. So I probably plug in 1, 2, 3. Okay, so plug in the -1/2. What do we get? 1/4.
Minus 1/2.
Good. And then, right. What's 1/4 minus 1/2? -1/4 minus 3. -3 and 1/4. And so when I go to mark that, that's right there. And that puts it exactly where we thought it should be. Just below, very close to those 2 dots that we already had. Okay. Now, if I plug in 1, what do I get?
1 plus 1 minus 3.
1
-3.
plus 1 minus 3, which is -1. I can mark it. That's right there. Now reflect it. 1.5 to get to the axis of symmetry. So 1/2, 1 to get to the other dot. Okay, so this is looking pretty good. How about 2?
4 plus 2 minus 3.
4 plus 2 minus
Which
3.
is positive 3.
That's 3. Okay, so we go to 2, and then up to 3. 1, 2, 3. And then I can reflect that. 1, 2.5. So 1/2, 1, 2.
I think 3 is going to be out.
You think 3 is off the grid? Yeah, we're getting kind of close.
Yeah.
Wouldn't take very long to check, though. So 3 squared is 9, plus 3 minus 3. We got 9. Now, 9 is off the grid, but it's very close, actually. We can kind of put a dot on there. So 3, 7 at the top, and then 8 and 9. We can get a reasonably accurate dot there. So then reflect it. 1, 2, 3.5. 1/2. 1, 2, 3. It's always good to have that dot so that we can get a good looking parabola up there. Okay? It wasn't too tough to get that extra dot. So now we can draw that in. Okay.
No, it's just
How do I draw that line? Where do I start? Start at 0? How come?
Oh, yeah. So there's no.
It's not that there's no y-intercept. There is one. But since we don't see a number here, what is it?
1.
It's 0. we didn't write a y-intercept, that means that it was 0. So we're going to start at 0 for our y-intercept. And then what?
-1.
The slope is -1, so where do we go?
Down and then to the right.
Down how far?
1.
And then how far to the right?
1.
Down 1, right 1. And we landed on a dot. Continue. And then reverse it. Up 1 instead of down 1. Left 1 instead of right 1. So up 1, right 1. Up 1, left 1. And there we go. We landed on another dot. Continue. And then draw the line all the way through the grid. Arrows on the ends. Okay, are we done?
No. Ordered pair.
What are the ordered pairs?
-3, +3.
And?
1,
-1, -1. So these ordered pairs, remember, represent the places where both graphs exist. Okay? These ordered pairs would be solutions for both equations. So if you wanted to check yourself to make sure that you're right, what you would do is you would take the first ordered pair here and you would plug it into this equation to see if you get a true statement. Plug it into this equation to see if you get a true statement. And if you got a true statement in both, then you were correct. And then you would do the same thing with the second ordered pair. Plug it into both equations to see if you got a true statement. If you did, then you were right, and the answer is correct. Okay? Now, in chapter 6, you learned how to solve systems of equations using substitution. We can do the same to these types of problems. We can use substitution. But after we substitute, remember that you're finding where the graphs are crossing somewhere on the coordinate plane. So that means we're not just solving for x, we're actually solving for an ordered pair. So you have to find the actual ordered pair. Don't forget that. Okay. Now, also, after you substitute, you're going to need to get everything on one side, so you have 0 on the other side. Okay. This is a little bit different than what we did back in chapter 6. And then once you have 0 on the other side, because we have that squared term, you're going to use any method we have so far to solve the equation. So that means you're going to factor. Factoring is always easier than using the quadratic formula, but if it doesn't factor, then you can go to the quadratic formula to find your x value. Once you have your x value, then like I was talking about, you can go and find your y value by plugging into one of the easy equations. So that part is just like chapter 6, okay? So, and then always check your answers to make sure that you're right. Here are a couple of examples of that. So in this, we have a parabola and a line. If these cross, we want to find where they cross. We're not going to graph, though. We're going to use the algebra, okay? So that means we're going to use substitution. Elimination doesn't work, by the way, for what we're doing here because we cannot eliminate a variable. We can't choose to eliminate a variable. Actually, if we use substitution or elimination here, we could eliminate y, but the point is we're going to use substitution. So when these two graphs cross, the y variables here are the same. So that means I can take what y is in this equation and substitute it into this equation for y, okay? So since this y is the same as that y, this equation gets substituted into that y there. Basically what happens is the two equations are now set equal to each other. So what I have is x squared minus 6x plus 10. I don't know what happened there. That's a plus. And okay, so the board is being weird. Plus 10 equals 4 minus x. The two equations are set equal to each other. Okay? Now what we want to do is get everything on one side, so we have equals 0. So we're going to add x. Oh, that was an x. Sorry. Plus x. But I'm also needing to get rid of this 4 on this side so that I have equals 0. And I think at this point in algebra, we probably can handle doing both things at the same time. Is that accurate? So how would I get rid of this 4 at the same time?
-4.
Subtract 4 at the same time. Okay, so all in one move now.
X
X squared
minus 5x
minus 5x
plus 6 equals 0.
plus 6 equals 0. So I'm kind of pushing you guys into next year's class where we start doing less of this step by step by step and we start handling multiple things at the same time. Okay? So we have x squared minus 5x plus 6 equals 0. We want to solve this equation now for x. So that means if it factors, we want to factor it. So that's always my first move because that will always be faster. Okay? So try to factor it. I would need two numbers that multiply together to give me positive 6, which means they would have to have the same sign. And they're going to add to give me negative 5, which means they both got to be negative. Negative 2 and negative 3 is right. So x minus 2 times x minus 3 equals 0. Now that it's factored, we use the zero part property. So x minus 2 equals 0. X minus 3 equals 0. And then we just solve. So add 2. X equals 2. On this one, add 3. And x equals 3. So that just tells you what the x coordinates are where these two graphs cross. We have to figure out the y coordinates so we can write the ordered pairs. Okay? So we plug these guys back into either one of these two equations. Whichever one seems easier is the better one to go with. So that's going to be the bottom equation. Okay? So we take 2, plug it in. 4 minus 2 is 2. So for x equals 2, y will equal 2. And then we do the same thing for 3. Take 3 and plug it into the bottom equation. 4 minus 3 is 1. So when x equals 3, y will equal 1. Now we could have used the top equation as well, and we will get the same thing.
But it just takes longer.
It takes longer. It's a more difficult problem. Okay, so that's why we use the bottom equation. So now we just formalize the answer as ordered pairs, and we'll be done. We have 2, 2, and we have 3, 1, and we're done. So to check your answer, to make sure that you're right, we already used the bottom equation to come up with the full ordered pair. So we just go to the top equation to make sure that we got the same thing. So we take x equals 2. We have 4 for the first x, right? We have negative 12 for the second x. 4 minus 12 is negative 8 plus 10 is
No, 2.
2. So we got the same ordered pair. So that means that we're good with that one. And then 3, we take 3 and we square it. Here we got 9. And we take 3 times 6, we got negative 18, right? 9 minus 18 is negative 9 plus 10 is 1. We got the same y value there. So that's how you check. Okay? The second problem. What should we do?
You gotta minus 12 and add y.
We want y equals. Okay? So get everything on one side and 0 on the other happens after we set them equal to each other. But in order to set them equal to each other, we need y equals first. Okay?
So we just add 30 to these.
So we're going to add 30 to both sides. Once I do that, I have y equals 12x plus 30. Now I can set them equal to each other. So I have x squared plus 11x minus 12 equals 12x plus 30.
And we subtract 30 and we subtract 12.
Do everything at the same time. We're going to move everything to the left side because that's where the x squared term is. Okay? And we want the x squared term to be positive. So the x squared term is positive. So everything's moving to the left side. So subtract 12x. At the same time, we're going to subtract 30 because we're creating 0 on the right side. All right, what do we have?
X squared minus
X
x
squared minus x.
minus
Equals
0.
Okay. Now, If it factors, we want to factor it. We don't want to go to quadratic formula because it's too time consuming.
So we need negative and positive.
Opposite signs, and they add to -1. So they're only going to be 1 unit apart. 7 and 6, which one is negative?
-7.
Right, -7. X minus 7, x plus 6 equals 0. Now what?
0.
Okay, so x minus 7 equals 0. X plus 6 equals 0. And then we solve these guys. X equals 7 minus 6. X equals -6. Okay, now what happens?
Plug them into the top equation.
So I would use the top equation, but I'm actually going to use this one here where I modify it. That's right. So I have 12 times 7,
84.
84 plus 30.
114.
So I have y is going to be 114 when x is 7. And then I have x is -6 this time. So it's going to be 12 times -6.
Negative 42.
Negative,
42.
not 42,
-72.
-72. Then I'm going to add 30,
Get negative.
and now it's -42. So y will be -42. Okay, so are we done?
No, you gotta write the order.
Yeah, now we got to write the ordered pairs. So you will get marked wrong if you don't write the ordered pairs here. So 7, 114, and -6, -42. Now you're done. So you can also use the graphing calculator to solve systems. And I haven't spent a whole lot of time talking about the graphing calculator. And unfortunately, I can't show you the graphing calculator on the video on this Promethean board because of the way that it's connected to a Chromebook. So I'm going to have to stop the video here and show you the calculator on a PC. So unfortunately, I have to stop now.